Hello everyone, welcome to another Open Cluster Management community meetings. Today we have two topics. We're excited to have Quinn Hao, who's have an enhancement proposal for the placement API, and if there's time permits, later we can discuss the Helm chart to install OCN, and if we can use some toolings to help us with that. So without any further delay, Quinn Hao, please take it away. Thank you.
Hello, let me share my screen. Okay, hello everyone. This is Qing Hao. Today I want to share is about the proposal about the placement extensible scheduling. There is a PR in the enhancement repo. This proposal is about the placement extensible scheduling. The whole proposal we want to provide an API to represent the score of the managed cluster, so we can support placement extensible scheduling. The background is when we're implementing the placement resource-based scheduling, we found in some cases the prioritizer need extra data to calculate the score of the managed cluster, or more than the default value provided by the managed cluster CR. So for example, there is a requirement to schedule based on some resource monitoring data from the cluster. Also, we want a more extensible way to support scheduling based on customized scores. The goal of this proposal includes we want to design a new API or a CRD to contain the customized score for each managed cluster. And also we want to let the placement prioritizer to support rating cluster with the customized score provided by the new API. Non-goal includes we won't consider how to maintain the lifecycle of the CR, how to create, update, and delete. This is out of scope. And also the placement filters will now support the new API. Okay, so next let's see 4 stories about this. The first story is that users could use the data pushed from each managed cluster to select clusters. So on each managed cluster, there is a customized agent monitoring the resource usage. For example, the CPU ratio of the cluster. It can calculate a score and push the result to the hub. Then, as an end user, I can configure my placement YAML to use this score to select clusters. Story 2 is a bit different, is that the users could use the metrics collected on the hub to select clusters, while story 1 is the data is pushed from each managed cluster. So on the hub, there is a customized agent to get metrics from the tunnels. It can generate a score for each managed cluster. And as an end user, I can configure my placement to use this score to select clusters. Story 3 is for the disaster recovery case. The disaster recovery workload could be automatically switched to an available cluster. As an end user, they have 2 clusters, a primary and a backup cluster, on which the workload storage is configured to storage. It's configured so storage is synced from the primary cluster to backup. And as an end user, I want to deploy my workload on the primary cluster first. When the primary cluster is done, the workload should be automatically switched to the backup cluster. And story 4 is that users could use the data provided by third-party controllers to select clusters. And a third-party controller can comprehensively evaluate clusters on latency, region and IOPS, and so on, and rate clusters according to the SLA on the cluster can provide. And as an end user, I can configure my placement to use this score to select clusters. Below are some detailed designs, include our new API called Addon placement score. We want to add this new API to represent a list of the scores of one managed cluster. This API represents a bundle of scores of the managed cluster. and it could be used by the placement. This API is a namespace scoped resource, and the namespace is the cluster namespace. The API don't have a spec so far. All the information are stored in the status. In the status, there are 3 sections. The conditions contains the different status of this CR, and the scores is a list of score items. It contains this score item. It contains a score name and a score value. For example, your score name is CPU ratio, and the value could be 100. Is your score. And also the valid until. This field defines the valid time of the scores. After this time, the scores are considered to be invalid by the placement. And if this is null, it means it never expires. The controller owning this resource should keep the scores up to date. Okay, this is the new API, Addon placement score. And next, to support rating cluster in our placement, we add field tab, score resource name and score name to the prioritizer config. So you can specify in the customized score to sort clusters. The prioritizer config located in the placement spec. Inside the prioritizer policy, there is a list of configurations. So for each configuration, in current status, you can define their prioritizer name and weight to specify which prioritizer you want to use and the weight of the score. And to support customized score, we want to add type, score resource name, and score name to this configuration. The type could be either built-in add-on score or empty, where empty is built-in by default. When your type is built-in, you can still use the built-in prioritizers. And if you define the type as add-on score, you can use the prioritizers can use the score provided by Addon placement score to prioritize clusters. And the score source should be defined in the build score resource name and score name to specify which score you want the prioritizer to use. And for score resource name, it's just the Addon placement score CR name. When your type is Addon score, you need to tell the prioritizer which CR you want to use. And the score name is easy to understand. As the Addon placement score contains a list of score name and value, you need to specify the score name so that it could be used by the prioritizer. Okay, above are the changes about API. Next, we'll talk about how to let the prioritizer support rating cluster with the customized score of the CR. There will be some detailed examples, and you can have a better understanding of the API. As the goal and non-goal mentioned, how to maintain the lifecycle of the Addon placement score CR is not is out of scope. And here we suppose there already are some placement score CR created in each managed cluster namespace. And a valid Addon placement score CR is as below. In the status, there are conditions and valid until, and a list of scores. And this CR name is default, it's for the cluster 1. Also, as an end user, I can define a placement as below to use this score in the Addon placement score to sort clusters. You need to remember the CR name is default. So here in the placement, we define a prioritizer type is Addon score, and the prioritizer is resource ratio CPU with weight 1, and the score resource name is default. This prioritizer, we want to use the score of CPU ratio, so we define the score name here. And for the built-in prioritizers, here you can see you don't need to specify the type. So for the built-in prioritizer, the usage is the same as before. Okay, when this placement created, the placement controller will sort the cluster with built-in prioritizer steady and add-on score prioritizer resource ratio CPU. The built-in prioritizer, how it's scheduling, the behavior keeps the same as before. And for the add-on type prioritizer, the scheduling process is as below. For the first schedule, the prioritizer resource ratio CPU will get customized score, the CPU ratio from a CR name default, and it will calculate a final score for each managed cluster. And so how to trigger a reschedule? As the scores inside the add-on placement score are supposed to be updated frequently, so rather than watch the changes in the CR and trigger a reschedule, the framework would periodically reschedule the placement like every 5 minutes, so to reduce the workload for the placement scheduler. This process is quite easy to understand, but there is a special case is what if there is no valid score generated? For example, what if the add-on placement score CR is not created for some managed cluster? What if the score is missing in some CR? And what if the score is expired? To handle these invalid cases, we add a pre-score in the prioritizer interface, so we can do some pre-check before we score the cluster. The pre-score, we can do some preparation work before we score the cluster. And then with the pre-score added, the add-on score type prioritizer, the scheduling process can be like this. In the first score, first we go into the pre-score. The prioritizer will check if 80% of the CR have a valid score. This number is just a reasonable threshold we hardcode so far. It might be configurable in the future. And if more than 80% CRs are available, we will continue to score the clusters. And if no, we will terminate this scheduling and wait for the next reschedule. And in the score, the prioritizer will still get customized score from the CRs and calculate a final score for each managed cluster. Yeah. This is for the first schedule, and for reschedule, in pre-score, we still check if the CRs are valid. If yes, we continue to score, but if no, so that means the valid scores are lower than 80%. So we want to remove the managed cluster. We want to remove the managed cluster which has a invalid score from the placement decision. So for example, if in your previous placement decision there are cluster A, B, and C, when the available scores are lower than 80%, and your manager C will have an invalid score, we will remove that cluster from the placement decision. If yes, we continue to score, so this is the same behavior. The future work is there might be a cluster scope CRD to configure the threshold of each prioritizer. For example, the frequency to trigger a reschedule, and the threshold to treat the cluster score as valid. Next is how to maintain the life cycle of the add-on placement score. This is out of scope, but we still have two options we want to mention to maintain the resource. First is you can write a customized controller running on each managed cluster. Let this controller to maintain the lifecycle, create, update, and delete of the CRs. Another option is we can let the placement controller to create and delete the CRs for each managed cluster. And for the customized score provider, they only need to write an agent to update the scores. Okay, next we'll have two examples. The first example is a customized controller can update the scores to API for managed clusters, and users could use this score to select clusters. So there will be a customized controller create a CR named default for each managed cluster, and it will also update the scores, CPU ratio, and memory ratio into this CR. The example is as below. The name is default. The namespace is so one managed cluster will have one CR in each namespace. As the conditions, the valid until defines the valid time, and there is a score list. CPU ratio have score 88 and the memory ratio have a score 77. To use this data, the users can create a placement as below to sort the cluster with CPU ratio. And here we want the number of clusters is 3. The mode exact and configuration, we define an add-on score type prioritizer, and we specify the CR name as default and the score name is CPU ratio. In that way, this placement can select clusters by the CPU ratio score.
Can you use more than one configuration there?
More than one do you mean multiple prioritizer here?
Yeah, since it's an array, I assume you can put one of.
Oh yeah, you can write multiple prioritizer here.
So what does it do if it has more than one?
I think you more than one. For example, you can still use the same prioritizer, but the score source is different. Or you can use another prioritizer.
I guess my question is, so if like if I put a configuration and I had a second add-on score for memory, and that one looked at the memory ratio, how does it work with how does it treat the weights?
So each prioritizer will give a score for each cluster, and the final decision is made by the total score of each managed cluster.
Gotcha.
It's a weight. It's a product of the weight and
perfect. Okay.
score.
Okay. Next example is about the disaster recovery case. The disaster recovery workload could be automatically switched to an available cluster. So a user have two clusters. One is primary, one is backup. There will be a customized controller update score into the CR, and the primary have a score of 100, and the backup have a score 0, and the valid until is nil. This score will never expire. These are the add-on placement score for the primary and backup cluster. You can see the namespace is primary, and there is a workload score. For primary, it's 100. For backup, it's 0. With these two CR created, to deploy the workload on the primary cluster, user can define a placement as below. The prioritizer name is disaster recovery. The CR name is what you created in the CR, and the score name is a workload. And the number of clusters is 1. So with this created, the cluster primary has a higher score, and the placement decision will choose the primary, and workload will be running on it. When the primary cluster is unavailable, there will be a tent added to the cluster, and then when in the next schedule, the placement will filter out the primary because of the tent, and then the backup will be chosen. Then the disaster recovery workload could be running on the backup cluster automatically. Okay, that's all for the proposal. Any questions?
I have one question for the add-on score, add-on placement score. So as you know, there is many types of the metrics. For example, the max memory. So it is a responsibility for the add-on placement score controller itself to mapping the different metrics to the final score, or there is a way, a standard way to do that.
I think in the suggested way, you should write a controller to calculate the score by the controller itself, and will only provide a placeholder to put the score.
Okay. So that means when I implement a add-on, a third-party controller, I can do it by myself, and I can translate the score by myself in any way. Is that right?
Yeah.
Okay, I see. Thanks.
Yeah, I think the scores in the scores calculated from the matrix there, each dimension of score has different ranges. So I think I kind of do not understand if it makes sense to sum it up, because for example, if the CPU ratio, we got a for example, we got a 200 weight, and in another matrix memory ratio we got a 2000 range, then I think just adding summing them up doesn't make sense a little bit, I think. But that kind of reminds me of another project, which is the Auto, which is majorly solving the similar problems of washing the data from matrix for automated canary release. They are using some kind of data processing techniques. For example, they will assert the scores calculated from the matrix using U-test or the Mann-Whitney test, which is a few mathematical toolings from the statistics. Like if we can, for example, like normalize the data calculated from the matrix, so that they can at least mapping them into the same ranges, then the adding them up will make more sense, I think.
Yeah, I agree with what you said. This part I missed to mention it. So here the score item, the value, we have a range here. So we want the customized score to be normalized before you update it into the CR, and the range is -100 to 100. So, yeah.
Okay. So minus value means rejection, is it? It's not recommended to scale. I guess if I'm a user trying this, I'd like to see some more tutorials or the recommended approach to, for example, an example program how to map the scores from the matrix.
Qiujian, do you have any comments for this? Okay. So our original idea for the negative is same as what you said. So negative score means we don't recommend you choose this cluster. But you know the final decision is a total score of all the cluster prioritizers. So even it's not recommended, it might still be chosen by the placement decision.
Yeah, sorry, I'm on mute. So I think that makes sense that we should provide a tutorial on how this value should be calculated based on a third-party controller. But yeah, so initially the -1 means that you don't want to put that, but I mean that means you're less likely to to select these clusters.
Thanks. And in addition to that, I'd like to see if we can have a progressive control of the when the topology of the placement changes, when the placement decision changes. Sometimes we don't want the just everything to be updated so too dynamical. I mean, for example, if we can inform, we can there in the another API we have a field named the remediation type. So for example, if we are if we are dynamically calculating the placement decisions from the prioritizers, when the score changes, like when the score changes too much, then we can just inform the administrators that so that the admins can approve to proceed or just let the system keeps in the old state. This will be helpful for example, preventing the system to be auto control, to be more controllable. Sometimes considering the stabilities.
You mean that you want the, I'm not quite sure about the role of the admin here. You want the admin to control the update frequency of the score, or?
Not about the frequency, but for example, when if we have 10 clusters, and then we're gonna select two clusters out of 10. Then for example, if the third scored the third greatest scored clusters there's a topology change, then it's originally if it selects the number 1 and number 2 cluster, then it's then the next moment is number 1 cluster and number 3. Then we don't like to see an fully automatic change made to the placement decisions. We hope the admins to control the process of cluster the placement decision change more progressively, like and approve and accept, like a
Yeah, I think today we don't have the so today in placement there's a static plugin, but that doesn't mean that the admin can control that. It's more like when a user try to select the cluster, you can set whether you want to stabilize the decision. I mean, for example, set a static with a higher weight, which means when you select the cluster at the first time, the static will not affect. It will just use other things like CPU ratio to select the clusters. But when the cluster has been selected, then in the reschedule process, I mean, in the next schedule run, the static plugin will participate. And if the weight of static is high, it means that the user for this placement one, the decision doesn't need to change frequently. But will that make sense or helpful, or do you think? I mean, it seems like you want a process that the admin here can do something, but I'm not quite sure what the process will look like.
Yeah, I just think about that, and it can be kind of out of scope. We don't see the similar kind of progressive controls either in the cluster autoscaler or pod autoscalers, but I think that's the from our perspective of cluster admins running the huge clusters, we don't like to see like big the everything's changes too dynamical, too reactive,
Okay.
considering the stabilities.
So maybe it makes sense that the admin can set up some basic weight or default weight or profiling that Yana has also mentioned before, that they can provide a profile of the scheduler. So they can say that in the profile, they can say that I want things do not change to dynamic, or I want things to change dynamic more.
Yeah, but for now, I don't have any constructive points. So,
I see.
yeah.
I think that makes sense.
Hello.
Well, that was
Hello.
hi.
Yeah. I have one question. So how we calculated the final score? It just simply summed up the built-in score and all the add-on scores, or we have any other method to calculate it?
It's just a sum with multiplied by weight. So, for example, in here you have the score of the static and the score of add-on score. That will each prioritizer will provide a score, and we will multiply by weight and sum them together.
Okay, so at the previous questions, all the add-on placement score will calculate the metrics to the score by themselves. So I don't think it is reasonable to just sum them up even by the weight, because different add-on placement score will use a different mapping method to map the metrics to the final score. So do we have any general method for the add-on placement score to mapping the metrics to the score?
I think we don't have that in the document, but that's a good suggestion that we should have at least some recommendation on how to implement the third-party controller.
Right. So yeah, my question is, for example, if one add-on placement score map the max memory, if the host have a higher max memory, it can map it to a negative score, and another add-on placement can map the higher max memory to a positive score. So how we calculate it?
Yeah. So I think from the process, we hope that so you have a score resource name, and which means the CR name of that score. I mean the resource name of that score, and I hope that we hope that the controller, the third-party controller, will use that one. I mean, it will create the score with the same name in different namespace. So, for example, in the default score in all the cluster namespace will be generated by a single controller. But you certainly can select another one. So I think your question is, for example, you have two third-party controller. One create a resource name called default, another one create another score named default one, and in default, the CPU ratio score is high when the CPU ratio is high, but in default one CR, it's reverse. So what I mean, that seems to me like normal things, like you can choose which one you use, but when you use the two together, it just add it together. So do you see any issues there?
No, not so far. But my second question is, from my understanding, the placement prioritizer will use a final score to prioritize the management clusters. So when we use a weight to sum up all the scores, either the built-in scores and all the other add-on scores. So with these different add-on scores, I don't think that just summed up them does not make sense.
So you think that doesn't make sense, or
Sorry, my primary concern is when we use a mixed up score, all the scores mixed up should have a stem mapping functions for the different metrics. So if the different scores have a different metrics, I don't think it makes sense to sum them up.
Yeah, maybe. I think that actually the things that we want to do is you can, for example, so there are some scenario like in the building we have the static and the balance, and the user might want to use other matrix to select, but so with the mix-up you can do something like I want to select the cluster the first time based on the ratio, but I don't want to move them too dynamic. In that way, you can choose to mix a static plugin, which is a built-in plugin, and another plugin that provide a score based on the CPU ratio. I cannot think of a user scenario that you want to mix the CPU ratio and memory ratio together to provide a final score.
Right.
But maybe that's not what we want to achieve here. What we want to achieve here is something like that. You can select different kind of the score and you can mix them to provide some advanced scenario, like you can try to balance the decision, but based on that, you still can select the clusters based on the CPU ratio. You can select based on CPU ratio, but make sure that your decision is stable enough. That's what we want to achieve. But maybe that's something that we should mention in this talk, that what's the best way to do that. And
Okay. So for now, so I can either use the final score to do the prioritize, and can I use only one score, either the built-in score or some of the add-on scores to do the prioritize?
you can. So in the prioritized policy, there's a mode. You can select that saying exact. It means that what exact prioritizer you want, and then
Oh, okay.
list all the ones there. But there's another one called additive. Additive means that there will be some default plugin that is default added into this placement, and you can add additional ones. So yeah.
Okay, I see. Thanks.
Hey, by the way, hello?
Yeah.
Oh, by the way, I just noticed that the scores are actually integer type. So, and it's normalized to range minus 100 to 100. So I see a high chance that there can be, the scores can be equal, can be conflicting across different clusters. So I wonder if we'd like a final granularity of scores, or the other way around, if we can make the score a float type, or instead of integer, but if we are using integers, I think we should clarify the path of how the multi-cluster scheduler decides when multiple clusters are sharing the same scores.
Okay. Yeah. I think that makes sense. I'm not quite sure whether floating. I heard that the floating is not quite supportive in the JSON format. But I think having a document having some descriptions in this document about how do you calculate a score and how do you build a third-party controller based on the matrix or based on other things makes sense.
Yeah. Overall, if we can have a few outstanding working libraries of the add-on placement decisions, then that will be more convincing. Because even for me for now, I'm just not sure if the everything will be working together in one piece in real productions. So
Okay.
more libraries and tutorials, or more comprehensive libraries will be more convincing.
Okay. Yeah.
But scheduling is a complex thing, so we can't go too far in the first stage. So we can probably start by figure out a roadmap of but I think but at least a few one or two working examples will be really convincing, will be really helpful for us to understand how everything's working.
Yeah, I agree.
Are there any other questions or suggestions? I think Kin Hao has noted some of the comments in the meeting notes already. So that was some really good discussion. Are there any more discussion regarding this placement enhancement? If not, I was gonna talk about how if we should host a Helm chart on the GitHub repo. But it seems like we're a little bit out of time for this week's meeting. So maybe I'll push that until the next meeting. Are there any objections to that? Okay, if not, then thank you all for coming. If there's no other topics, see you guys in 2 weeks. Take care, everyone.
Thank you.
Bye-bye.